Hey, welcome to Unit 4, Lesson 1, which Unit 4 is going to be about polar coordinates and conic sections. And today's specific objectives, we'll read through them right here because this is going to be some new information. We're going to plot and identify points in the polar coordinate system. So this is new. We're going to convert points and equations between rectangular form and polar form. And we are going to graph polar equations on a Cartesian plane. So in order to be successful through this, we want to bring back some old information you have discussed probably in Algebra 2 Trig, and that is just remembering how to draw angles in standard position. And remember, standard position means we're going to start from the positive x-axis right here, and then we are going to rotate that degrees or radian measure and then write our, draw your radius from wherever you end up. So 120 degrees, remember we rotate 90 degrees to keep going to 120. So my terminal side would be right here. So this would be 120 degrees. Recall, if you have a negative value, you are going to go backwards. So negative 30 degrees. So my terminal side is right here. So we're rotating clockwise instead of counterclockwise. If we do radians, 3 pi over 4, it's positive, so that's going to cut us right in half. This is 3 pi over 4 radians. Here's my terminal side. And then if we rotate negative 7 pi over 6, that's slightly bigger than 1 whole pi. We're going in the opposite direction. So there's my terminal side. So hopefully that was a quick review. And that's it. We'll move on. Okay, the rectangular versus polar coordinate system. You guys already know rectangular coordinate systems. You've already used it. It's the X and Y or Cartesian system. We go horizontally, then we go vertically to get a specific point. We call that X and Y, our X coordinate and our Y coordinate. But let's say we don't want to move vertically or horizontally, we don't want to, specifically move to the right so many or left so many, up and down. We can use a different system, which is called the polar coordinate system. So the polar coordinate system uses r and theta, where r is the distance from the origin to the point, and theta is the angle of rotation from the positive x-axis. When you have points in this r theta, we call those polar coordinates. So r and theta are polar coordinates. You can think of r as a radius, right? And then of course a radius from the origin here or from the origin here. So the radius, you're going to go out so many. So if we wanted to get to this point, we would say we're going to go out a specific distance of the radius, and then we're going to rotate a specific, because that's going to be a circle, so the radius of the circle until we get to that point. So we go out a certain length of the radius, and then you rotate a certain angle measure to get to the same point as if moving right, x coordinate, and up, y coordinate. So let's practice, because that's what's going to help you kind of learn this new system. We're going to plot each of these and label them A, B, C, D, E on the same grid. So this first one, we have a radius of 3, so we start from this origin, we go right 1, 2, 3, and then we rotate pi over 4. Well, pi over 4 is going to be halfway around, so right here is point A. But let's go back and look at this coordinate system and try to figure out what these measurements are. So this is obviously halfway through, which is 90 degrees, is pi over 2. This is pi, and then down here is 3 pi over 2, and this here is 0 and 2 pi. Halfway in between, this is going to be your pi over 4, right? 3 pi over 4. You can go around and do all these measurements. But if we're going 1, 2, 3 sections to get to pi over 4, right, then what are we counting by? We have 1, 2, 3, 4, 5, 6. So there's 6 sections here. So all the way around there's 12 sections, right? So that's 12 pi over 12. So this is 1/12. Which means this is 2/12, which is pi over 6. 3/12, which is pi over 4. This is 4/12, which is pi over 3. And then you could continue to see this going all the way around if you want to continue to fill this out, but you don't have to. Okay, let's look at this one. We have a negative. What happens when your radius is negative? So there's 2 ways you can deal with this problem. what you're supposed to do is go out 1, 2, 3, 4, which is the radius length, and then rotate pi over 6 units, which would put you here. Except it's a negative radius, which means you're going to go in the opposite direction. So instead of out 4 with the rotation, you're going to go backwards on that same line, 1, 2, 3, 4. So point B is going to be located in the third quadrant over here. So we would rotate the pi over 6, go out 4, but then you have to go in the opposite direction because that's what the negative sign means. It means you're going to go opposite, in the opposite direction. Okay, let's try the next one. Do that one green, letter C. So we have a positive 2, I'm right here, then I'm going to go backwards rotation, pi over 2 units. So you are going to end up on the y-axis, negative y-axis. So that's our C. Let's try yellow for D. D, we go out positive 2, a radius of positive 2, and we rotate 7 pi over 4. So that's 1 pi over 4 to 3 pi over 4, 5 pi over 4, 7 pi over 4 is right here. So this is my letter D. And then for letter E, I'll do that one in black. So we're going to go 1, 2, 3, 4, 5, and then rotate backwards 5 pi over 6, which is here. However, remember that was a negative radius, so we have to go 1, 2, 3, 4, 5 on the same line, 1, 2, 3, 4, 5, and this is where your E is going to be the opposite direction. Now I initially told you up here you could do this 2 ways. You could go out your positive radius, rotate, and then go on the opposite direction. Or what we could have done, you could have said, okay, if positive is to the right, then negative is to the left. And you could have gone 1, 2, 3, 4, 5. And then you could have rotated backwards negative 5 pi over 6, and it would take you to the same location that we got originally. So you could go backwards first and then do your clockwise motion or backwards rotation of your angle because they're both negative. So have a think about that. If you're confused, then make sure you ask. So now we have we're going to do exercise 2 and see what happens here. It says, what is the difference between 2 pi over 6 and polar coordinate negative 2, 7 pi over 6? Let's sketch to find out. So maybe pause and do this on your own. So I'm going to do 2 pi over 6. So I go right 2, up 2 pi over 6, so that's this point here. Now if I do the second point in blue, I'm going to go negative 2, and I'm going to go 7 pi over 6. Remember, that's a positive rotation, so 7 pi over 6. This is 6 pi over 6, so 7 pi over 6 is going to end up right exactly where the first point was. So what is the difference? There is no difference. They are the same point. Right? So there is no difference here. So let's look at this nice little section on the right hand side. It says if R is positive, the point will be in the same quadrant as theta. So theta was in the first quadrant, R was positive, so we ended up in the first quadrant. If R is negative, then you end up in the opposite quadrant. So when I rotate to 7 pi over 6, I'm here in the third quadrant, but really my answer, because R was negative, is in the first quadrant. So it's the exact opposite quadrant that you were originally in. So that's a nice little tip. So it says in polar coordinates there are literally an infinite number of coordinates for any given point. Why is it infinite? So think about that. Why is it infinite? Well, that's because you can rotate around this circle an infinite amount of times in a positive direction or in a negative direction to land on that same point. So I could just add 2 pi onto this or subtract 2 pi over and over and over again to get the same answers. Okay, it says, for example 3, sketch 5, 3 pi over 4, and identify 3 other polar coordinates on the interval from negative 2 pi to 2 pi that represent the same point. So let's start with just graphing this first point. So we're going to go out positive 5, 1, 2, 3, 4, 5, and we're going to rotate positive 3 pi over 4. So here's my point. So now I need to come up with 3 different ways to identify or land on that exact same point if I were to graph. So I'll give you a hint. 2 of the ways are going to have positive r's, and 2 of the ways are going to have negative r's. We've already listed one of them. It's right here. So 5, 3 pi over 4 is one way. So to get another positive radius, I'm going to go out positive 5, but instead of rotating the positive direction, I can now rotate the negative direction. So it would be positive 5, negative 5 pi over 4. Then I could do a negative, two ways to locate that point with negative 5 to start with. So remember, if I go to negative 5, I'm going to go 1, 2, 3, 4, 5, and I can rotate my opposite direction, or the negative direction, or I can rotate the positive direction. So if I rotate the negative direction, that's going to be negative 5, negative pi over 4. And if I rotate the positive direction this way, it's going to be negative 5 and 7 pi over 4. So what do you notice here about your final answers? Two of them have positive, oops, sorry about that. Two of them have positive R values, two have negative R values, and two of them have negative angle measures, and two of them have positive angle measures. So that's always going to be the case. Now let's go back and say, why did we give you a domain restriction? Well, that's because of the infinity aspect. We could have listed an infinite amount, so we're going to restrict that domain to force you to only look at angles that are caught between negative 2 pi and 2 pi, or we could restrict it to 0 to 2 pi, or negative 2 pi to 0. We could do a lot of different things to make sure your angles are stuck in between those two in that interval. Okay, and moving on here to example 4, it says plot the point 4 root 3 and find all polar coordinates that describe the point from 0 to 2 pi. So this is a rectangular coordinate, right? So if we were to plot that, we would go to the right 4 and up 4 root 3. Well, if this is x and this is x root 3, this should remind you of something you learned in geometry, which is that relationship of x root 3, 2x. That then means that this angle measure is what? Well, you might be saying that's 60 degrees, because across from 60 degrees is bigger. So the shorter side is x. It's a 30, 60, 90 degree triangle. The shorter leg is x. The longer leg is x root 3, and the hypotenuse is twice that. So twice 4 is equal to 8, so my radius has a length of 8. And then our angle measure we said is 60 degrees, but we're going to only deal with radians, so we need to translate 60 degrees in radians, which is pi over 3. So it says find all polar coordinates that describe that from 0 to 2 pi. Well, the first one is going to be 8 and then pi over 3, right? So we go out 8 and rotate up pi over 3. And then my only other option is to go negative 8. So I'm going to go out here and I'm going to rotate the negative angle measure, the negative angle measure, but that doesn't work, right? Because that's not going to be a number that's caught in between. So we have to go out positive 8 up here, or out negative 8 and rotate this direction, which is a positive direction. So that's going to be 4 pi over 3. I ran out of space here. I'm not sure I explained that very well. Sorry. To get your other one, again, this angle has to be caught between 0 and 2 pi. So if I go negative 8, I have to rotate in the positive direction because this is a positive angle measure. So it's 1 pi and then a pi over 3 more, which is 4 pi over 3. Moving on. Okay, Cartesian coordinate system. To polar coordinates. So Cartesian to polar conversions. It says now that we've got a grasp on the polar coordinates, we need to think about converting between two coordinate systems. If we have the rectangular coordinates, which are x, y, we can solve for r using the Pythagorean theorem, right? If this is x and this is y, well, x squared plus y squared equals r squared, right? And r is the radius in the polar coordinate system. So r squared equals x squared plus y squared. We can also solve for this angle right here. If we have the rectangular coordinate, that means we have x comma y, right? So what trig function connects y and x to each other? Well, that's our tangent. So tangent equals y over x. So if we have our polar coordinate, which is our theta, then we can use sine and cosine to write equations for x and y, right? So cosine of theta with our unit circle, or you can just put that's x over r. So r cosine theta equals x, right? So the radius times cosine of the angle measure is our x coordinate, and our y coordinate then, remember, is going to be our sine theta. So this is polar form because it has your radius and your angle measure. This is polar form because it has your radius and your angle measure, where x and y are rectangular because it's just your x and y coordinate. So this methods and meanings here below just kind of highlights that. So polar to rectangular, we're going to use this. If we're going rectangular to polar, then we're going to use these two formulas. So we'll see what that means as we continue with example problems. So let's do some example problems to see what we're doing here. So it says convert to rectangular coordinates. Convert to rectangular coordinates. So we have a polar coordinate. We know that r equals -4, and we know that theta equals 2 pi over 3. So if we're given r and theta, we just said that x equals r cosine theta and y equals r sine theta. And we want to find the rectangular coordinate, which means we're trying to find x comma y. So all we're going to do is plug in. It's -4 times, cosine of 2 pi over 3. And then this is -4 times sine of 2 pi over 3. So cosine of 2 pi over 3 is what? So you might want to pause here and try that on your own. So I'm running out of room, sorry. So -4 times 1/2, so we get a -2. And then for sine, it's -4 times √3 over 2. And so we get -2 √3. Now I made an error here. Hopefully you guys know what error I made. What did I do? I did cosine of 2 pi over 3 should have been a negative because that's in my second quadrant, right? And only sine is positive in my second quadrant. So I knew that as soon as I made this positive, I started to think about it. So negative times negative, this should be a positive. So it's 2 comma -2 √3. Why don't you pause and try letter B on your own? So once you paused, you should see that you should have gotten a positive 3/2 and positive √3 over 2. Again, if you think about this, this is going to put you in quadrant 1. So both of these ordered pairs, or both these coordinates, sorry, should be positive. And they were when I did the math. So you should have gotten 3/2 and √3 over 2. Okay, moving on to exercise 6. What if we're going to convert to polar, sorry, we were given rectangular and now we want to convert to polar just through the interval of 0 to 2 pi. So we have our rectangular. So the first thing I'm going to do is I'm going to graph it. So I go to the left 1, up 1. So my triangle is in quadrant 2. I go left 1, up 1. So I need to find my angle measure here and I need to find my r. Well, obviously the r is probably going to be easiest to do first. So r squared equals -1 squared plus 1 squared. So basically r squared equals 2, so r equals √2. Remember, it's a radius, it has to be positive only. So I have a special case triangle right here. It's 1, 1, √2, which means this angle measure is pi over 4. So if I'm in the second quadrant, I can either go out positive √2, right out here, and then rotate positive 3 pi over 4 to get to this point. Or I can go -√2, so I go back this direction, but I still rotate positively, and that would be a rotation of 7 pi over 4. So there are my two polar coordinates that represent that point, but those polar coordinates are specifically have angles that are caught between 0 and 2 pi. So why don't you pause and try letter B on your own. So you should have gotten 2 and 5 pi over 3 and -2 and 2 pi over 3. So I drew my right triangle. I saw it's another special case triangle with the angle measure there of 60 degrees or pi over 3. So I'm either going to go out my positive radius and rotate all the way around a positive direction, 5 pi over 3, or I'm going to go out my negative radius and just rotate, oops, sorry, I don't know why I did it that far, and rotate from here to here, which is my 2 pi over 3. So those are my two options for 6b. All right, moving on. Okay, now what if we have some graphs? We're going to do some graphs and see why they are the graphs they are. So example 7 says graph each of the following polar equations, convert to rectangular coordinates if possible. So this first one we have is r equals 3. Well, the only connection we had was that r squared equaled x squared plus y squared, right? Well, this isn't r, it's only, or sorry, it's not r squared, it's only r. So if you square both sides, then we get r squared equal to 9. Well, if you change r squared into x squared plus y squared, then suddenly you see that we have a circle with a center of 0, 0, and a radius of 3. So basically, r equals 3 was just telling us it's the radius length of a circle, so we go out 1, 2, 3, and the center is at 0, 0, or the origin, and so that is the graph for letter A. All right, so we have our x and our y coordinate system, or our Cartesian coordinate system there as well, and then our polar, we'll put those circles on it to kind of help us with the rotation and identifying the radius length. For letter B, we have theta equals pi over 6. So the only thing we know about theta that involves theta is tan of theta equals y over x. So we're just going to plug in our theta, which is pi over 6. And so now if you were to do your special case triangle, right, it would be 1, 2, root 3. So tangent of pi over 6, this is pi over 6 here, would be root 3 over 3 or 1 over root 3. If we isolate the y, we get root 3 over 3x, which is an equation of a line. It's an equation of a line that's going to go specifically along which one of these radii right here? Well, it's going to be specifically along the pi over 6 rotation, because that creates the slope of root 3 over 3, or 1 over root 3x, because of that special case triangle relationship right there. If that was your origin, you'd be going up that slope. So theta equals pi over 6 is just a line across whatever that angle measure is, and r equals 3 is a circle about that radius, with a radius of that length. Our next two, sorry, I got a little messed up here, so I rewrote them. So for letter C, it says r sine theta equals 2. Well, remember we said that r sine theta is equal to y, and x cosine theta is equal, or sorry, r cosine theta is equal to x. So this is an r sine theta, so we can just basically replace that with a y. This is the same as y equals 2. So we go up 1, 2, we draw a horizontal line because that's what y equals 2 looks like. So that's it. It's the same as a horizontal line. This would be the work that you would show, y equals 2. So it's a horizontal line going through 2 on the y-axis. If you look at letter D, we could rewrite secant as 1 over cosine theta. Then you can move that to the other side. So r cosine theta equals 1. And now you're going to replace r cosine theta with x. So in other words, that's just a vertical line going through 1 on the x-axis. So there we have it, vertical line going through 1 on the x-axis. Okay, our final example is doing a graph. It's a little more complicated, and it's going to lead us into graphs later on in the unit, but it's still not so difficult yet. So I rewrote, because you can't see this angle or the equation up here, function, so r theta equals 2 sine theta. So you can fill out your table if you want for the sine curve, right? So if we plug in a 0 here for theta, well, the sine curve at 0 is 0. At pi over 6, what are we going to get? So you can do your unit circle if you want to. So 2 times 1/2 is just going to give us 1, and then we're going to get 2 times root 3 over 2, which is going to give us root 3. 2 times 2 times 1 is 2. 2 times negative, or sorry, no, it's still positive. Sorry. We're going to get root 3 again. 2 times 1/2 is 1, and then 2 times 0 is 0, because your y coordinates of all of those. So if we graphed that, notice this only goes from 0 to pi. So we graph 0, 0, then we graph pi over 6, 1. We can just call 1 here, and then 2. So graph pi over 6 is 1. Oops, pi over 6 is 1. Erase that. Then we do pi over 3 is root 3, which is 1.7 something. And then we come down and we fill in the rest. So we have this portion right here. Now notice I started right here and I went this direction. Now why did I not continue? Well, you could continue, right? You would have all your negative section here. So we'll talk about that in a second. Let's just work with this part only. So it says sketch this equation again, but this time in terms of y versus x. So we would have 0, 0, and then out here we would go out 1 and rotate it pi over 6. So we're right here. And then we would go out root 3, which is 1 point something, and rotate pi over 3, which is up here. And then we're going to go out. So does everyone understand what I'm doing here? Sorry, maybe I should have made that a little more clear. Here I'm at a radius of 2, so I go out 1, 2, but I'm rotating pi over 2, so that point is here. Maybe I should have color coordinated. This was going out root 3, and then I'm rotating pi over 3. This one was going out 1, rotating pi over 6, so I keep going. So now I'm here at this one. I'm going to go out root 3, which is 1 point something, and rotate to 2 pi over 3, which is right here. Oh, sorry, not on the axes, just in a little bit. Then I'm going to continue 5 pi over 6 with a 1, so I go out 1, but I'm rotating 5 pi over 6, so I'm here, and then I'm back at pi, which is over here at this angle, and going out 0. So what did that make? Well, actually what it made was a little circle, right? And maybe you don't know or you don't see the circle that well, but this is a little circle if we call each of these 1, 2, 3, 4, 5. But what we're going to emphasize this unit is starting point. So where did we start? We started at 0, 0. So you would say, okay, this is my starting point. And then we're going to emphasize two things. One is going to be your starting point, and the second thing is going to be your direction that you're moving. So we went from 0, 0 to 1 to this direction. So we're going around the circle counterclockwise. So we're going around the circle counterclockwise. So your direction arrows will be going here. Now, notice I completed one full loop. So I started here, I completed one full loop of my circle at pi. If I continued this sine curve here, what would happen? Would I create another circle down here, or would it overlap itself? Well, maybe pause right now and try to figure that out. So what did you notice here? Hopefully you noticed that when you did this second part right here of the cosine curve, or sorry, of the sine curve, that you would repeat and overlap that circle once again. Because right here we have, right, a negative radius, so we would be going out a negative radius, or rotating, I should say, something larger than pi. So I rotate something larger than pi, but my my radius is all now negative. So when I rotate down here, I'm flipping up to the opposite side, rotating, flipping up to the opposite side, rotating, flipping up to the opposite side. So all I'm doing is going around that circle for a second time. Starting here, looping around the circle for a second time. So you're looping around the same circle a second time. So I'm running out of space here, so I can't write. So looping or going around the circle a second time. So the other thing I wanted to emphasize here is, what is this? This is just a circle. What do you notice about this circle? So when we had this r of theta equals 2 sine theta, it's just a circle with a the center is now at 1, 0. So it was shifted vertically, right? Vertical shift, which notice, well, yeah, vertical shift, and then it just has a radius equal to 1. So radius equal to 1, vertical shift here. So that is also what I want you to notice. So you can practice, go see your teacher. This is really hard to do a video. See a teacher if you have more questions. And yeah, see you in class.